So just like though you understand about the concept of the algebra, we can also be able to multiply the two vectors. But the multiplication has to answer choice. We have what you call the cross product of the vectors, of which the result will be also the vector itself. And now we have what you call the dot product, of which the result has to be a magnitude or the single value. So let's start with the cross product of the vectors. So what is that one? Let's say we have a vector. Let's say a vector A. Let's say in a component form has been given as, let's say, 2, 4, let's say 5. And we have a vector B in a component form being given as, let's say, a 5, 1, let's say 2. Now it should be this in this way. Now, what is the cross product of the vector A as well as the B, if this is the case? How should you be able to have that and out? So in this case, we should have to come up with the actually it should be the actual x-axis, that is I component, and this is the j component, that is x actually should be y-axis, and this is the actual z component given as, let me just have to use these hats. So that is, in a specific manner we should have to present the components, that is to be in a 3-dimension, I, j as well as the k, representing x, y as well as the z. So that is, then we should have it in this way. What we are to go for is the determinant, so we'll have to present this in this niche. Of course, it has to be not basically as big as it is, but should be this. Let me just have to restructure the process here. It should be, it should be like this at least. So which means I'll have, this is I, this is j, and this is the k. So the vectors I'm having, we have this is I, j, and this is the k. So mind you, for you to operate the cross product, the vectors has to be in 3-dimension. So should it be that the vectors are in 2-dimension, then you should have to include the dimension which is missing as the 0. So that is, let's say we have, now in this case we have is 2, 4, and this is 5. And then we have 5, 1, this is 2. So should be that. So now, in this case, we'll have it as this case now. So we'll have, now should be this, we'll have the I component. So start with the I component. So now in this case we'll have to eliminate this component. It should be, this actually should be, this column has to be eliminated, in the sense that we'll only have we'll only have these 2 columns. So in this case, these values will be for I in that way. Or else let me just have to also tell you something you should have to know. So what do is this? We say the first law, the first column. It means the component that has been eliminated, it is the I component, which is to be presented in that way. So which means the values that are there, it means they are for I. So which means we'll have it as 4, 1, 5, 2. So should be that. Then we'll have it as a minus. We'll have now the j. So should be like that. It means also do the same, the first law in the second column. We have eliminated I. That will be for that component. So which means we are having the values 2, 5, and I'll have, now should be this case. So should be 2, 5, and I'll have 2, should be 5, down 2. So like that. Then we'll have plus C, and we'll have the K component. In that case, we'll have it in this case being eliminated, and only having it as 2, 5, 4, 1. So that is the essence behind that in that case. We can have to operate it in that way. The next is to have it as now I component, now have it as the open bracket like that one. So have 4 times 2 times 4 times 2 minus 1 times 5. So that's the format that you have to go through in all those components. So have it as a 4 times 2 minus now 1 times 5. We'll have that one as that. Then minus, let me just have to use the hats. This is physics, by the way. And can be, you can also present them in the same way as these, but you know, much as I understand much about the physics, the way you have to present this, but also mathematics concept, it takes the same actual format. Although some books are actually, they present with these dots, but I prefer using the hats. You know, I much concentrate on the physics whenever I was talking about these things. So that is, so which means also have 2 times 2 and minus 5 times 5. So we can have something that, so that is then plus should be now a K component that is now given as 2 times 2 should be 2 times 1 like that, minus now should be 5 times 4. So should be that. In this case we'll have it as I component, having it as 8 minus 5 should be that, and a J component having it as should be 4 minus 25. And to have the J actually K component having it as should be 2 minus a 20. So we'll have it as that. Now we can have it as this case now. So have it as 3 actually I and plus, because 4 minus 25 is given as negative 21 times this negative, have it as a plus, so have it as a 21j, and now have it as negative 18 actually k. Now this is the actually a cross product of those two vectors. You should have to know. Now what if we have a vector c with now in a unit vector notation given as 2i minus, let's say, 2j minus k. Let's say that's the case, and now we have the vector d given as, let's say, negative 4j and minus should be 2k. So now what is the cross product with these two vectors? We should have to know. So now principle remains the same. Cross product of the vector c and a vector d has to be given as, now have to present the components in a specific manner like this. So now in this case we'll have it as we can have it as this. Principle means the same, nothing new here. So now have it as 2, and I'll have -2, and I'll have -1 as it stands there. It means we're having the -1k there. Now for this one, we'll have a -4, and this one is having, actually this vector D has no j component. That will be given as our here. Then you have -2 being given as that. Then now we can have it as this. Now we'll have I component that will be now being given as this. So which means we'll have to pick these two, those two, we'll have to pick those two. That will be given as the -2 is our -1, -2. So should be that. We'll have now j component that will be given as, so which means I'll have -2, -4, and then -1, -2 down, should be that. And the plus k component that will be given as now 2, -4, -2, 0. Now write that. So should be like that. Now in this case we'll have it as I component, which is given as the -2 times -2, we'll have it as 4. So have 4 minus 0 times -1, we'll have it as negative. Actually it should be minus 0. And we'll have minus, should be a j -2, actually 2 times negative, a 2, have it as -4, and minus -4 times actually 1, we'll have it as a 5. So also have that's actually something like that. And the plus a k component that will be given as 0 minus, should be 8. So in this case we'll have it as 4j, and I'll have it as plus, should be 4i plus 8j, and the minus 8k. Now this is the cross product of those two vectors. Now the point of interest is, how can you be able to have the magnitude of the cross product of the two vectors? We should have to understand as well, much as you know how to find the magnitude of the vector, this is also the same principle as well. For instance, let's say we have a vector x. Let's say it is given as, should be 2i minus, let's say 4j plus 10k. Let's say that's the case. And we have the vector v being given as, let's say -2i and plus 5j minus 2k. Let's say that's the case. So now, what is the magnitude of the cross product of the two vectors if that's the case? So this symbol represents that we should have to go through the magnitude of the vectors upon having the cross product. So now the essence behind it is, much as you already know how to find the magnitude of the vectors, we'll have it in this case the square of, so now which means we'll have the x square plus a y square and a plus c square. So which means the x component to the power 2 and the y component to the power 2 and the z component to the power 2 will have the magnitude of the vectors in that way. So take note of that. Now at your own time, try to go through this to have the cross product of the vectors. Even if you wish, you can also be able to have their respective magnitudes. Now let's say we have a vector O given us, let's say -20i minus, let's say k, and now we have a vector B given us -5k, and now we have a vector k. Let's say we have a vector that should be, let's say, vector S. We have a vector S given us, let's say, negative I, negative J, negative K. Let's say that's the case, and now we have a vector D being given as, let's say, negative 15 I minus 10 J minus 2K. And we have the vector C being given as, let's say, negative 3 I minus F5J plus should be 8K. So now find actually evaluate the following. Let's say the cross product of the two vectors, O as well as the B, and C cross O, and also should be now B. This is the B, and the C should have to operate what you call the C cross B as well in that case, and also D should have it as S cross O, and if you can also go through their respective magnitudes. So take note of that. Now how about the dot product of the vectors? So now the dot product results into what you call the scalar value, while the cross product resulted into what you call the vector itself, as you have recently witnessed. So let's say we have a vector A given us, let's say, 2I minus 5J plus, let's say, 12K, actually 12K should be plus 12K, and we have a vector B given us, let's say, a 3I minus, let's say, 2J minus 2K. Let's say that's the case. So what is the dot product of the two vectors A as the B? So according to the principle behind, you should have to understand it in this way. So have actually a 2I minus 5J plus 12K and a dot, or have a 3I minus 2J minus 2K. You have that and as that. So have to multiply these vectors componentry. Actually componentry, it means actually I will have to multiply with I, and also J's together, and also K's together. So if we multiply the vectors in different components, it means those components will be given as 0. So hence we just have to literally multiply the vectors componentry, and that will have their respective magnitudes. So what is that on? So in this case we'll have it as actually 2I times 3 actually I. We'll have it as just a 6, and we'll have it as a plus negative 5J times negative 2J. We'll have it as also, we'll have it as a plus, we'll have it as a plus 10. So that is, then we'll have 12K actually times negative 2K. We'll have it as a plus negative 24. So this is the same as having it as 6 plus 10 and minus 24. So which means we'll have it as, now this is 16 minus 24. So you can take it okay there. What if we have this case now? Let's say we have, actually you'll be able to proceed that on at your own time. You know, I've just left it for you. And what if we have this case? Let's say have a vector U with components given as, now should be 0, 1, 2, and that we have the vector V with components, let's say negative 1, 0, 5. Let's say that's the case. So what is the dot product of the two vectors if this is the case? So now the principle behind remains the same. We'll have 0, 1, 2, and that dot the vector negative 1, 0, 5. So which is the same as 0 times negative 1, we'll have it as a 0. And the 1 times 0 we'll have it as plus 0, and I'll have it as plus 10, which is equal to 10. So that's the cross product. Actually, that's the dot product of the vectors. You should have to know. Now, what if we have this case? Let's say we have the vector w, and they're giving us, let's say, 21i minus 2j plus, let's say, 11k. Now we have the vector actually y being given us, let's say, 2i minus 20j and minus 2k. Let's say that's the case. So what is the actually a dot product of the two vectors? So which means we'll have it as, now the 12, actually 2 times 21, we'll have it as a 42. We'll have it as a plus. Now have a 20 times, actually negative 20 times negative 2, we'll have it as a positive 40. So now have it as a positive 40. And we'll have 2 times, should be negative 2 times, now should be a negative 11. We'll have it as a positive, should be 22. So that's how you have to understand that and up to. Now generally, let's say we have a vector v with, let's say, a components given as vx, vy, as well as the vz. Now we have the vector u given as ux, uy, as well as the, let's say, uz. So according to the principle behind the dot product of the two vectors, now this thing will be given as ux times uy should be ux times vx plus ui times vy, and that plus uz times vz. So this is the general form. So at the end time, also try to go through the dot product of the two vectors for the vectors I've given you in the context of the cross product. So that's the essence behind the cross product of the vectors as well as the dot product.